I would like to welcome to the stage Camille, Mackenzie, Hema, and Ashley for a panel discussion on AI and workforce transformations. Welcome.
All right, well, thank you, Dana, for the introduction. So my name is Camille, and I will be the moderator for our panel discussion today on AI in the workforce and also the future of AI. So a quick introduction about myself. I got my PhD in applied mathematics from Clemson University, and then I was lucky enough to start my career here at NextEra as a data scientist. I got to work on a lot of really interesting projects in natural language processing, and then also some more classic machine learning things like classification and regression. Just last month, I moved up to the DC area where I am working at MITRE, which is a government contracting company. I'm still a data scientist, just learning and applying, my skills in other areas now. So now we will turn it over to the panelists. So for this first section, let's just go, person by person, and then after this, we'll make it a lot more, conversational. But for your introductions, I want to know about your education and career background, and then also what is your favorite part of your job or data science in general?
All right. Hi, everyone. Thank you for joining us today. My name is Ashley Etemadi. I had a bachelor's degree from the Wharton School at the University of Pennsylvania, studied decision processes as part of the Operations and Information Management track, and then recently graduated from the Harvard Grad School of Education, studying human development and psychology. So I started my career at Accenture in New York, working as a management consultant, and then I transitioned into working for a startup in Colombia, Bogota, where I was there as a fellow, working with a micro VC that was building companies for middle-class Latin Americans. And then from there, I went on to a company called TopTal, which is the largest network of vetted freelance talent globally, and launched TopTal Finance. And most recently, I joined Harvard's Next Level Lab, where I do research at the intersection of emerging technology and learning sciences.
Thank you.
Awesome. Hello, everybody. My name's Mackenzie. I graduated from Florida State University back in April of 21 with a Bachelor's of Science in Computer Science and a minor in Math. So my career started last year, July of 21, with NextEra Energy. I am part of the Ignite Leadership Rotational Program in the IT track. So I've been in 2 departments so far. The first one was IT Nuclear, and now I'm in FPL Solutions. So while I was in IT Nuclear, I did some data science work. I was working on a PDF mining project actually with Camille, and I was also a Scrum Master, and now in FPL Solutions, I am working on cloud cost optimization.
Hi everyone, my name is Hema Raju, and I come from a healthcare background, so I'm kind of a loner from the rest of the gang here. I did my master's in biophysics and a PhD in human genomics from the University of Miami with focus in bioinformatics. And it was actually my thesis work that steered my career into the world of data sciences, because as part of my PhD thesis, I developed a computational algorithm that detects specific kind of genes or, like a non-coding RNAs in certain neurodegenerative disease model. So I was at the University of Miami for almost 12 years, working as a research associate to bench scientist, and then transitioning into the data scientist role. And I worked for a couple of CROs where we led a team of data scientists trying to look into the design, develop, and implement the risk-based monitoring model, because the clinical trials, the critical part of clinical trial is the quality of the data, right? How you identify the patients, how you identify the sites, because identification of the site and the patients are a critical part of the success of the clinical trial data. So I was involved in mostly like predictive analytics study, and recently I joined another pharma company where my role is to act as an analytic consultant to enable data-driven insights through advanced analytic model to support our clinical development, asset management, and operations. So yeah, that's pretty much about me. Thank you.
All right, thanks guys. So before we move on, do you guys have anything to add about the favorite part of your job or your favorite just data science topic in general?
I think the favorite part of my job is looking more, so I look more at the human side of the human-machine partnership. So more at kind of what are humans unique at that machines cannot replicate. And I think what's interesting is I have to constantly be on top of advancements in the AI space, because the field is progressing so rapidly, and new technologies are coming out, like we just talked about Affectiva. And I actually used a technology that was very similar in grad school that was an emotion detection AI algorithm that could tell me when I was smiling or when I was frowning. And the cool part is I have to be on top of that new technology to understand kind of what is actually uniquely human and how do we train people in those areas so that they can be successful and work in partnership with machines.
Sure.
So generally for data science, my favorite part is the data exploration phase, just because I think that's the phase that kind of prompts the most creativity. So once you start learning about the data, you can start to brainstorm about how you're going to solve that problem. And I think that's my favorite part, because you can take all that you learn and kind of apply it to solving the problem at hand. For my job specifically, I just started a new rotation in FPL solutions. So I'm working on the finance side to optimize the cloud costs. So for me, the most interesting thing related to data science has been seeing how some of those tools can use those machine learning techniques. So for example, AWS Budgets is one of those tools that we've been looking at to use, and it uses machine learning techniques to kind of forecast budgets in the future based on your past data, and I thought that was really cool.
Yeah, I mean, there are many things I could say that fascinates my role as a data scientist. To start with, first of all, every day you're tackling so many creative and challenging problems, right? You deal with massive amounts of data coming from different data sources, especially I deal with medical data. We have so many data sources. We have data from patient claim, lab data, image data, EMR data. They say that the healthcare data is the most messiest data ever, right? So when you're dealing with such kind of data, you are always constantly thinking and trying to improve your skill set, because what works for one project may not work for another project, because the data is so different, and whatever the methods and modeling tools that you're trying to design, develop, and implement may not work for any of the two different projects, because they differ from each other, right? The other thing is, like when I was working with my risk-based monitoring tool, right? You would think that, when I say there's so much, so much data anomaly, data inconsistency in a clinical trial data, right? Especially in South Florida, where we pursue these clinical trials, we have same patient going to the two sites that are 10 miles away, I mean, how do they not think that we can track them down? It's the same name, same date of birth, age, BMI, everything, right? So those kind of interesting facts, what we try to identify through our model is what fascinates us. So yeah, that's a lot. Thank you.
Yeah, Mackenzie, I definitely resonate with what you said about the creativity. Because my favorite part about being a data scientist is like working with people to solve problems and figuring out how to solve it. And a lot of that lends itself to, whiteboarding sessions and really talking to the end users of our models to figure out like where exactly is the pain point and how can we fix it, how can we help you. So I definitely find that to be like my favorite part of my job as well. All right, so next question that we have is, throughout your careers or life in general, what types of situations have you seen where you've thought AI or machine learning could really help this process?
I'll pass it off to my co-presenters.
So one major thing that I noticed when I was in nuclear is the app team I was working on did mostly manual testing for UI. And that's fine. I think it's something that they were working on kind of developing for the future as automated testing. But I think that can be really useful, right? Because if we have machine learning picking up on how to write tests and automatically execute them, they can identify quick fixes to developers before someone has to go through multiple different test cases to find that. So I think that's definitely something I picked up on.
Right. So, yeah, I mean, definitely within the scope of healthcare and pharma, there's so much scope for the implementation of AI and machine learning model, because I think we are still in a budding stage, compared to the other industry. We are still in a crawling stage. We have so much to do. I personally feel that these models can help us stratify and help produce, better solutions towards, especially to start with the EMR data set, right? EMR system, how we can implement these models to help refine our EMR, the electronic medical record system, how we can standardize and optimize the way that these systems are designed to help with, to cut the cost for the patient care. And these models can also be applied to, create a breakthrough research in oncology to obtain those medical and clinical data and deliver personalized treatments for more specific for the patient needs. That's a whole another precision medicine area, right? And yeah, there are some research papers that have been published how these AI models can also help with the early detection of certain rare diseases, using the genetic data, and highlight the specific opportunities of certain clinical trials, and also pinpoint a specific targeted therapy. So yeah, I mean, definitely we do need to move forward with the application of the machine learning models within the scope of the clinical trial data as well.
And then even in like a high touch area like learning, we're starting to see AI in terms of supporting teachers or educators, both at universities or in companies, understand how people are interacting with those learning experiences. Are they struggling? Is a learner taking a long time? Is this too easy of a subject for them? Is this not enough of a challenge? And that helps provide really valuable information for educators to then tailor that experience to the learner so that they're motivated and actually end up having the outcomes that we're looking for.
Yeah, I'm sure with education, the pandemic, I'm sure, has really like kickstarted a lot of like technology for that as well.
Yeah.
All right, so next part, let's talk about the strengths of AI and humans. In what situation is AI better, and are there situations where we should maybe, avoid it and stick to the human decision making?
So the question is, if I have to put it in my context, I would ask, can AI outperform physician? The answer is no. Because I think at the end of the day, the physician recommendation is still critical to explain the AI findings as such, right? Because you may have an algorithm that probably detects your heart disease patients using certain specific characteristics, BMI, blood pressure, and say certain other markers, and may identify incorrectly a patient to be healthy without having an event of cardiac symptom or anything, right? But the physician who has a complete history of that particular patient may identify the patient to be unfit and unwell, which the algorithm failed to detect, right? So the end of the day, yes, the algorithm helps, but we still need the human intervention in order to answer the question, in order to identify those patient pool and to find out who are prone to have heart disease.
So Hema, does that also lend to like AI and ML helping doctors as well make decisions? Because especially if you have a model that can identify, like, we think it's this because of these factors.
Exactly. You know, I was actually, when I was listening to Rana's talk, when she was talking about the emotional IQ, right? So that involves so much human interaction, right? Which your algorithm or the existing data cannot read, right? I remember vaguely there was this study a few years ago. It was an immunotherapy study where they were trying to test a drug to see if it can reduce the size of a tumor. So what happened was, during the course of the trial, the tumor size kept increasing instead of reducing. So they were almost about to cease the trial because they said there was not worth pursuing the trial, right? And one of the site, the doctor intervened, and he said that I may have to talk to a couple of my patients, the trial patients. So, and when he talked to them and he asked them, how do you feel about this? They said, we're feeling much better than what we were before. So, and then they went back, and so the physician developed these follow-up questions, which your standard algorithm or your data or your scan could not obtain those insights which the physician was able to obtain. And after that, they continued pursuing the trial, only to find out that the tumor size was growing not because of the cancer cell as such, but it was because of the cancer affecting T cells. So it was going in a right direction, right? Had we just relied on the data, maybe we would have passed that, and we wouldn't have the FDA approved drug to reduce the solid tumors. So yes, in at least within the scope of medicine, both go along very well.
And Hema, I think that really goes back to, in our research, we talk about the complementary relationship between humans and machines, which we call intelligence augmentation. And AI is really good at what we call reckoning, so calculation, prediction, computation, those types of skills AI really excels. But then there's humans, right? And they are really good at what we call judgment, and judgment in the sense of the form of deliberative thought that seeks to be unbiased and grounded in ethical commitment and kind of very tailored to the situation. And so you need both, right? It's a conversation between the machine and the output that it's giving us, the information, the recommendation, and kind of that contextual knowledge that the human has. So going back to Rana's and Affectiva, it provides a lot of information, what you're getting about kind of the emotional state of the audience. But then what you do in the meaning that has for you is different based on person to person. So it's going to be really contextual how you respond. And I think both are important when we're working with machines.
Exactly. I agree, 100%.
All right, thanks, guys. I'm actually going to switch the order a little bit just because I think this is a good segue. So with the advancements in and adoption of AI, do you think any new types of jobs will be created? Or are there any current jobs that will grow or possibly change because of these new advancements?
Definitely. So I think both we should look at new jobs that are going to appear, but also the current jobs that are going to change. So in terms of the new jobs that are going to appear, I know Rana had some stats up, and the 2020 Future of Jobs report from the World Economic Forum predicted that about 85 million jobs would be displaced by the shift in tasks between humans and machines. So that division of labor is going to shift. But then on the other end, there's going to be 97 million new jobs that are created that are more aligned with this new division of labor between humans, machines, and algorithms. And then on top of that, the existing jobs that we have are also going to change as more of our tasks get taken up by machines. The composition of tasks that we complete are going to be different, so that machines are going to take up more reckoning, leaving us more time to dedicate to that human judgment aspect. So I think we have to look at both like new jobs, but also our current jobs are also going to change.
Yeah, and I'll add to the current jobs changing. So on a project that I was working closely with Camille on, it was for the power generation facilities and kind of suggesting maintenance for those plant components. So that was something that wasn't in existence before. So when you have AI that's kind of analyzing the components and coming up suggestions for those maintenance ideas, you didn't have anybody evaluating that before, and that's something that you need, right, is the experienced plant engineers to go through and look at those suggestions and decide whether or not to act on them. So maybe not exact like new jobs, but definitely those plant engineers are going to have to learn, and their tasks are going to be added to, obviously, with that new work.
Yeah, and that also helps just optimize like operations in general, because you have, as someone working at a power generation facility, you are one person, you are tasked with your daily activities, and you're not working 24/7, so you don't see, the overarching, I guess, operations of the plant, but that's something that the data can tell you more about. So in a lot of situations, it's just going to help make things run more smoothly, really.
Yeah, I agree.
Nothing, okay, that's fine. All right, so what skills do you guys think will be most important for data scientists to master in the next few years?
So I think from a general sense, just staying up to date and really learning and being aware of new technologies that are out there, because I think the data science community is ever evolving, and you have to be aware of those tools in order to become just efficient in choosing the right solution to a problem. And more specifically, I think cloud deployment is an area that data scientists should really kind of get up to speed with. Not that they aren't, but I think a lot of people are more focused on the actual application of the model, but things like code quality, that's something that can definitely delay deploying a data science solution, right? That's something that I ran into with the last project I worked on. And then also pipelines and issues that you can experience with deploying those solutions with the pipelines. And also cloud services. So we use AWS for our last solution. So it's good to be able to determine which solution to go with. So you have Lambda, ECS. It's good to know about your options.
And then on the non-technical side, I think just having human skills, right? So collaboration, you guys talked about creativity. These are really important skills that I think are going to become even more important in the future. Problem solving, knowing emotional intelligence, as Rana talked about. These are things that we don't necessarily learn in school in like a classroom environment, but they very much dictate how we conduct our jobs and how successful we are.
Yeah, especially because a lot of the times the consumers of your data science models aren't going to be data scientists like you are. So you need to be able to communicate with them what you're building and why things are working the way they are. And then also just building trust, right? Because they need to trust that what you're telling them is, accurate to whatever degree. So I definitely agree with that. I always said, from my math background, the biggest skill that I learned was from teaching, was just, conveying results and talking to people, so.
Yeah, and I think we all live in South Florida, and I think culture is another big one that we won't see AI at least replicating in the near future, is understanding cultures and the complexity of cultures. And I think that's another one that's really important for being able to be successful in a workplace, is being able to maneuver that. And I'm sure going from a data scientist and being in the culture of data science to then having to teach that to someone else, that's also a different culture, transcending in the workplace. So I think that's also going to be really important.
And I think that also means that, like going back to what Ashley was mentioning, that you always need to understand the business needs. That's the first step, right? If you do not understand the business needs, you cannot prepare your list of your questionnaires to address what the business needs is and work forward, and always be flexible. We cannot be streamlined with one particular skill set or one particular programming language, because as I mentioned earlier, data coming from different data sources, they vary so much, and you have to constantly upgrade yourself. In fact, there was also a survey done on the Stack Overflow recently with those developers, and they found out that 75% of those developers, they constantly upgrade their skill set every 5 to 6 months, because the packages, the modules, everything is so outdated. You have to keep in market. Yeah, thank you.
All right, anything else on that? No? All right. So thinking back to your college days or any other formal education that you guys have had, how do you think educators can best or better prepare students for a successful data science career?
I would say like project-based learning is a big one. I know in my schooling, well, I was in a business school, so in the business school we did quite a bit of projects and collaborating together, but my friends who were in the engineering program, it was a little bit similar, but maybe less collaborative, smaller groups, and it was all with engineers, but I think having interdisciplinary kind of problem-based projects is really important for designing classes that, for the future, for what people need to know going forward.
Yeah, I definitely think that seeing a model actually work on a data set that you're familiar with is way different than learning about the models at a high level. Like you could easily look up what's a regression model, what's a classification model, but it's a different thing to see that actually work on data you're familiar with. So for me, that was definitely a big thing.
Yeah, I mean, added to Mackenzie, I think the statistic is the backbone for data scientists, right? But I mean, even if you have a very strong programming knowledge background, it's really hard to, be the storytelling part of or interpret your data or your graphs or visualizations. I think most of the school do miss the statistics or even if people from different background, they want to pursue the data science as their career, I think one of the most important component is the statistics. I mean, if you could be strong in your statistics, that could help you shine as a data scientist very well.
Yeah, I agree with you guys. It's definitely a strong understanding of stats and really getting your hands dirty and getting used to like ugly data. I remember in grad school, some of my friends that were in statistics, they had to like collect their own data and build their own models trying to predict who is going to win the upcoming presidential election. So they were all, like it was a semester-long project and they were all like, kind of complaining about it and talking about how hard it was. And I was like, that sounds terrible. I'm glad I'm in math, But now that I'm a data scientist and, working with data and everything, I'm like, that was a really cool project that was very good exposure for people who are, still in the academic setting. So yeah, just real world projects. I love interdisciplinary is huge as well because we're always talking to people of different backgrounds and different education, and everyone brings something new, to the table. So thank you for saying that. All right, so for the last question of our panel, let's talk about how we can ensure that the people using our data science results understand the model and the potential incorrect answers that the model gives.
I think training.
Training?
I mean, like I was mentioning before, the plant engineers, that's not something that they usually do, is look at a data science model results and kind of decide whether or not to act on those decisions. So I think that they need to understand how the model works in order to use that data and the responses in the best way possible, but also be able to identify incorrect answers, because that's always something that we risk with AI.
Yeah, it augments human
Yes.
decision making. So
Yep.
they need to understand that, like what they think actually matters.
Yeah.
Yeah, and I think even understanding where the affordances of the model, but also the limitations of the model and being able to explain that and understand. So yeah, understanding exactly how the model works and like what are some errors that might come up, but also when do you not use the model, and when and what are things that could come up that that you don't know about. So I think that's important too.
All right, and with that, we are about out of time. So thank you guys.
Thank you.
Thank you.
Thank you.